The objective of the competition is to rescue a victim on one end of a table with a robot starting from the other end, which has to safely transport it down. A robot from this end will need to navigate the city blocks in order to meet with the rescue robot, grab the victim, then transport it safely to the hospital. We brainstormed several ideas for the robots. We thought about building a crane, since it could grab the victim and lower it down. But then we thought about claw machines and how unreliable and frustrating mechanical claws can be for grabbing stuff. So we needed to be smarter. We decided that we could build a sort of ambulance, but instead of navigating the city blocks, it'll just go over them. Then the rescue robot, with a forklift mechanism, will pick up the victim and rappel itself down the ramp, transferring the victim to the ambulance. The ambulance will then take it safely to the hospital. We fleshed out our idea, and eventually we were satisfied. Now it was time to start building. We started with CAD models for the rescue robot and ambulance, and designed custom wheels for the ambulance to go over the city blocks. We created the chassis for both robots out of acrylic sheets using a laser cutter. We wired up the motors, batteries, and Arduinos, and even created a winch mechanism for the rescue robot. Once we were done building the robots, it was time for testing. First, we tested the rescue robot to make sure it could detect the victim using a pixie camera, pick it up using its servo-powered forklift, and rappel itself down safely with the victim intact. Surprisingly, our first few trials were a success and only needed minor tweaking. The ambulance robot was a little tricky. We went through several design iterations. At first, the wheels were too far apart, so the ambulance would often get stuck on the walls. Also, its unique wheel design made driving straight especially challenging. Software glitches also tended to crop up at the worst times. After overlapping the wheels, implementing PID control for the ambulance's heading, and refining the code, the ambulance was finally ready to go. Now it was time to make the robots communicate with each other using XBs in order to transfer the victim. Using the power of the pixie cam and its color detection function, the rescue robot detects where the ambulance is, tells it where to meet, before lowering itself down and releasing the victim. It was quite a trial and error process. During the final competition, each team was given 3 rounds. When it was our turn, no team had a successful round yet. The pressure was high. Our first round was a failure. The ambulance misdetected the second wall and tried to drive to the ramp too early. Our second round was a bit better. The ambulance made it over the city, but for some reason, the rescue robot wasn't able to detect the position of the victim, locking up the robot. We ran a quick calibration on the pixie camera, and in our final round, the ambulance again made it over successfully. The rescue robot detected and drove to the victim's position, picked it up with its forklift, carefully aligned itself on the edge of the ramp, located the ambulance, and directed it into the correct position at the bottom of the ramp, rewound the winch, rappelled itself down the ramp, and successfully dropped off the victim, thus giving the competition its first successful run. The final competition was a challenging yet rewarding experience. We enjoyed the opportunity to develop a complex robotic system, utilizing creative mechanical and software solutions. As a team, we had lots of fun solving various challenges together, working with others, and facilitating a collaborative environment.